So, hi everyone. Yeah, we are live now. So, can anybody confirm me like I am audible as well as equally visible? You can share your views in a chat. Okay, so let me check. Okay. Thank you, Deepak. Thank you. So, let me introduce first. So, right now, my name is Nitin Kaplas, and currently I am mentor at Geeks. So, today's your contest will be taken by me. Okay, so yeah. So, how was your today's contest? Like, I hope today's contest will be very easy. Yeah, we have four questions, but currently in our coding contest 159, we have three questions. How many people are solved all the three questions? In today's contest, there is no DP. I think no graph will be there. Yeah, it's very easy. I hope many of you are doing all. Okay, the third one is little bit medium level questions, but I think first two are very easy questions. Okay, so Arun said एक भी नहीं हुआ. Okay, okay. So let me share my screen. Okay, so please confirm like my screen is visible to you now. Please anyone confirm in a chat so that I can start. Okay. Thank you, Deepak. Thank you. So let's first understand the first problem. So here the first problem is sorting items, right? In our geek land, each item has a unique identifier made up of uppercase English letter, right? We have the A to Z uppercase. So here the A represent number 1 and B represent number 2. Same as Z represent 26. So yeah, it's in the order, right? So here we have AA which represent 27 and AB represent 28, right? So meanwhile, let's follow our first example. In the first example, we have n equal to 5 and items we are given, right? In the form of strings. So our task is just to sort my string in terms of my integer values, right? So if you see here, I know that A will be 1 and B will be 1. So let's understand how this AA will be 27 and ABC is 731, right? So let's understand first these. So our input is DCB. First, let's understand how AA and ABC will be this integer values. Okay, so see here, we know that in a binary format, right? In a binary format, we just use here, for example, 1010 is there, right? So how we can calculate convert into decimal? Simple, we just convert like this, right? Okay, so with the help of this, we just convert that binary into my decimal value, right? So how we can convert a decimal value? Like how we can check decimal value? So if you see here, 1 to 3 we have, right? So decimal means 10, right? Its base is 10. Binary means its base is 2, right? So in the decimal part, we have 10 ki power 0, we have 10 ki power 1, we have 10 ki power 2, right? In this manner, what we are doing is 10 की power 2 into 1, what we have the value here, plus 10 की power 1 into what we have here, right, which is 2. Similarly, 10 की power 0 into 3 we have, right? So if you see here, 10 की power 2, which is 100, 100 into 1, 100. So here, what we have, it's 20. 10 की power 0, already we have 1, 1 into 3 is 3. So our answer is this, 1, 2, 3. Now in this question, here we have the characters, right, which represent from 26, 0 to 26. So what we are doing here, or 1 to 26. So in this case, we are given A and A. So similarly, its maximum value is 26. So we have to make like that, right? And we know that A is 1, right? So how we can written here 26 की power 1 into. So what is this? It's 1 plus 26 की power 0 into 1. So what we have? 26 plus anything, any number की power 0 will be 1. So here we have 1. So answer is 27, right? Now let's check for ABC part. In ABC part, similarly, we just have to write 26 की power 0, 26 की power 1, 26 की power 2, right? So let's calculate this. 26 की power 2 into what's the value? 1 plus 26 की power 1 into what's the value? B is 2 plus 26 की power 0 into C, which is 3. Now let's calculate. 26 into 26, 6, 7, 6. And 26 की power 1, that is 26 into 2, which is 52. Here we have 1 into 3, which is 3. Now what's the addition of this? It's 7, 3, 1, right? So that's why here our value of ABC is 731, right? Hope you understand how we can calculate in terms of integer, right? Now let's check how we can solve this question. To solve this question, first visualize this part. All the values, the in the string part, the size is 1, so it came forward, right, in the sorted manner. So here the size of A is 2, here the size of ABC is 3, so it came at the end. Now let's first understand, if my string is this and my value is this, so why I'm using this example, because here our size is 3, I know that, and here my size is 2, right? My string size is 2, but in two characters, in two size of string, I just create a maximum as I can, right? Here in terms of three size, I create as minimum as I can, right? But just think about this. In A part, if I write here 26 by 0, 26 by 1, 26 by 2, my answer will be something like which is this plus this, right? In terms of, if I calculate ZZ, right? So if I write here ZZ and it's 26 ki power 0 and 26 ki power 1. So what we have to written here, this into 26 plus 1 into 26, right? If just I just compare with this is cross, right? And this value is also crossed with this. So again, I have the maximum value of AAA. So what I want to tell you here is, our maximum value of string is depend upon its size. If its size is greater, so that will be our biggest integer, right? So how we can solve this question? To solve this question, let me create a same example, BCB, ABC and AA. So if I create this like this, let's suppose the first thing which came to my mind is, we are using here map, right? We have to use map, because with the help of map, I can segregate all the values based upon its size, right? So what's the size of first string? It's 1. So what I'm doing is, I create 1 and I add D into it. Now when I'm here, okay, so again the size is 1, right? I have the 1, I just add C into it, right? Again I go forward, yeah, size is 1. So what I'm doing is, I again add that B into my key 1. Now when I move forward, it's ABC, right? What's the size? Its size is 3. So let me create a 3 key and add ABC into it. Similarly, AA is here. So what's the size? 2. So what I'm doing is I push that AA into my key value, which is 2. Now it's very simple. Now, so here the problem arises, like we have DCB. How we can make them in a lexicographic order? So inside this, what I'm doing is I'm using map of intervalue. As here we are using intervalue, and inside this what I'm doing is, in terms of any vector or any other thing, what I'm using is I use multiset, right? So multiset stored multiple values, right? And at the same time they help us to create in a lexicographic order, right? Okay, so the multi-set property, I just explain a bit of it. Like we have the two properties. We can add multiple values into it, and at the same time, they help us to create in a sorted way, right? So how your map will look like is this. So B came first. After that we have C. After that we have D. Right here we have AA. Right, and here we have ABC. Right. So using this part, I easily make this. Right. So let's make a pseudo code of it. Okay. So inside this, what I'm doing is I just make a for loop of it, and I'm pointing all the items like what we are given in the question, right? We are given the vector of strings. So inside this, I create a size first, right? We have the size. After that, what I'm doing is, based upon the size, I just add that particular string into my corresponding key, right? So let's suppose here we have X, I'm adding into it, right? So these, with the help of these two steps, I easily make a map, right? First of all, I just calculate the size of X, right? After that, I just push all the values corresponding to my size value, right? After that, it's very simple. Just do a two loops of it, and store all the values into your, like, your vector, right? We have to return our vector of string, right? So let me create here. This is the first step. I just write the pseudo code, right? So inside this, what we are doing is I just pointing to my map, right? This is my map, right? And inside this map, what I'm doing is, like, I know that X is pointing to your first value, right? First key. Now I create a Y, which is pointing to my X dot second. Means it's values, right? Until it's not finished, I create a vector above it, right? And push all the values into it. At the end I just return my v. So here I just create a v, right? So as simple as that. So here the first step, I just create a map, and inside this map, right, I just segregate all the values based upon its size, right? And inside the size, I just want all the strings will be in the lexicographic order. That part will be help with the help of multi-set, right? Now the first step is over, right? So now I just traverse my loop, right, on the map. Now X is pointing to the first key, right? And inside this key, what I'm doing is my Y is pointing to X dot second. X dot second means this part, right? And until this is not finished, all the values I'm pushing into my vector, right? So here I'm creating a vector V. Now your X is pointing to this, and Y is pointing to inside your X, right? First is B. So let's push B into my vector. After that, it's C. After that, D. It means that the first loop is over, right? It means that this part is over. For X is pointing to the first key, right? Now X is pointing to this key right now, right? Which is 2. Inside this, Y is pointing to the first element of it, which is AA, and your inner loop will again finish, right? After that, X is pointing to the third element, right? Which is the key number 3, and Y is pointing to the first element inside it, which is ABC. Now I am pushing ABC into it, right? So this is our vector. This is what we want, right? This is our task. So this is our output, right? So let's code this now. So the first step is let's create a map of int and multi-set part, right? And inside this, I just traverse to my vector of strings, and inside this, what I'm doing is first let's calculate the size of it. So size is x dot size, and based upon size, I just add all these strings, right? Now the first step is over. Okay, so I calculate the size and put that particular string into that particular variable, right? Particular key. Okay, now let's create a vector of your string. Let me name as v, and now I just traverse my x upon my map, right? Now inside this, y is pointing to x dot second. Okay, now your v is push back y, right? Now all is finished, and let's return my vector. So let's compile and check. Yeah, the first step, and yeah, second. Let's submit. Yeah, all the cases are passed, right? Now let's talk about the time complexity. The worst case is your all the strings are of different size, right? And in a map, we know that like the complexity to add all the values is log n. So we have the maximum worst cases, all the values, all the strings are different size. So we have the n strings, and map create log n time, right? To insert all the strings into your map. So our complexity is this, right? And what's my space? So space, as I said, the worst case is all are different size, so our space will be big of n, right? So this is our time. So I hope you understand the first question, right? So yeah, the intuition is simple, like you just have to convert your character into your integer as you do in a decimal part or in a binary part, right? Okay, so if anyone have any doubt in first question. Yeah, the third one is based upon like yeah, binary search. Okay, so let's move to our next question. That is bridge on bits, right? That's also very easy question, right? Now, how we can solve this question is to solve this question. Let's first understand a bit of the question. The question said you're given an array, right? You are given the array ARR of length n. The task is to construct a bridge from array A, from array 0 to array n minus 1, right? Our task is just to make a bridge of all the numbers in the array is set to be complete if for any ith bit of all the numbers in the array have the same bit, means ith bit will be set. In one operation, you can flip any bit of a number in the array. If the bit is 0, you just have to convert as 1, or you can use a vice versa approach as well, right? So our task is to return the minimum number of operation required to construct a bridge. Okay, so let's first do the dry run for the first case. Our array will be this, right? Okay, so the question said like we have 1 2 3 4 5. Okay, so we just have to flip the bits, and we just return which flip, like what's your count minimum, right? So if you see here, what's your binary? Your binary is this. Here we have binary this. Here we have binary this. Here we have binary this, and here we have binary this. Now the question said, if you are standing at this part, right, at the zeroth part, So how many flip you have to convert in all the elements in your array to make all the bits set. So if you see here, this is already set. No need to convert it, right? If you see here, yeah, it's 0. We have to convert, right? We have to convert it to into a set bit. So our count will be 1. Initially it's 0. So when I see this, I just increment it. Now when I move forward, it's set. It's not set. So let's count this. Now my count will be 2. Okay. I want the minimum count, right? I want the minimum count. I want the minimum flip which we are using. So initially your answer, let me create here. Let's suppose your initial answer is infinite. Now what I'm doing is I just compare with my answer. So here, how many flip you have to make? 2, right? Our count will be 2. It means you have to flip 2 times. So let me update my answer, which is 2. Okay, so if this part is over, let's count for this part, right? At I equal to 1 position. Now if you see here, how many flip you have to make? 1, 2, 3. So my count here is 3. So I want the minimum, right? I want the minimum count. So can I update my answer? No, because I want the minimum, right? So here my answer remains same, right? Which is 2. Okay, so again I when I go forward, and when I equal to 2 position, again we have 3 bits, right, which is unset. It means again my count for this position is also 3, right? So my count is 3. No need to update your answer, right? Answer remain 2. Okay, so when I move forward for this part, right, all are 0. So it means that here my answer will be maximum, right? So it means your answer here in this case is 2, right? Now the question arises, how many bits like we have to check? Like meanwhile we are just calculate in a normal way 32 bits. But the question here tell you that that question will be in the constraint part, right? So the constraint value is 10 raised to power 18, right? As you know, like 10 raised to power 9, maximum bit we can have 32. But here the value is double. So how we can solve this question is very simple. We just have to traverse till 64 bits, right? So the first thing is we just traverse up to 64 bits, right? And inside 64, what we are doing is I just make a count which is 0. And as you know, in a like a bitwise part, what we are doing is we can use left operator as well or right. So here I am using the left part, right? So what I'm doing is I just shift my 1 I times to the left part, right? After that, what I'm doing just do the AND with my current value. Now I'm asking if it's 0, so just do the count plus plus, right? Now when particular bit at particular bit, like for example, when I am standing at I equal to 0, I just calculate all the elements at I position, how many times I have to flip. So that flip I already stored in my variable that name is count, right? So I want the minimum, right? So what I'm doing is I first of all I create a maximum value as much I can, right? Which is int max. So when my inner loop will finish, what I'm doing is I just compare with my answer, right? If my count is right, if my count is smaller than my answer, I just update my answer. At the end, what I'm doing is I just return my answer, right? So that's a simple approach to solve this question, right? So let's compile and check. Yeah, let's submit it. Okay, so yeah, it's 100% correct. So let's talk about the time complexity. Its complexity is, as you know, like in a outer loop, our loop will run 64, means it's a constant, right? Inside this, what I'm doing is I just make a traversal 0 to n, right? So the time complexity is 64 into n, right? So yeah, this is our time complexity of this question. Okay, so you just have to create note the two things here. we just have to traverse 64 times. And if you see here, the value is very large, right? So we just have to create here long, right? I just make a 1 with the L, right, which make it long log. So here many students I think make a mistake. So you just have to care of this. Like, so the first thing, you just have to focus on the constraint part, and after that just focus on like what type of data type it's used in your parameter. Based upon that, you have to solve your question. Okay. So if anyone want to ask in this question, yeah, you can uh, comment in your chat. Okay, so you can reduce like 64 to 60, like your roughly value of 10 raised to power 18 will be nearby of 60, right? Okay. So if you guys understood, please give me +1 in the chat if you want, so that we can move to our next question. Yeah, we have to use one, right? I hope you know, like in a bitwise part, in a left shift operator or right shift operator, we have to use one, right? We have to just compare with the one, right? So here, as I said, in a vector part, right, this part, you are given the long value, so that will be like represent with the L part, right? So the compiler will know, like, okay, so you just have to compare with the longest part, right? Because you just do the AND with the ARR of J, right? So ARR of J is of type long. So you just have to write here one, right? So that's why we have to make here L, right? L just represent. Can you just summarize it once? Okay. So here, as I tell you, you have the this values, right? The question is said this. Our question said, so the first step is, what you're doing is just create a binary of your like this value, decimal value. I just convert my decimal into binary part. Okay. Now, if you see here, when I'm standing here, the question said, at that particular bit, how many flip you have to make all the particular, like this bit all is set. If you see here, this is already set, right? This is not. So your count previously is 0. When I'm reaching here, my count will increase because it's 0, right? It's unset. I just want to make a count of how many times we have to set, right? How many times we have to flip. Here, I just make it 1, count 1. If you see here, this is already set. When I move forward, this is unset. What I'm doing is I increment my count. Here, it's already set. So my count here is 2, right? My count here is 2. If you see here, your outer loop will run from I equal to 0 until 64 bits, right? Now my count is 0, and I'm checking in the inner loop at particular bit how many count we have to make. So this checkpoint is tell you that that particular bit and that particular element of your array, is this set or not. If this is unset, I just increment it. When your this loop will finish for this case, right, when I equal to 0 here, all the elements you traversed it at particular bit I equal to 0, my count is 2, right? Now I have a variable answer, right, which is int max, which is very big value, right? So let me create here, answer is infinite. Now here, how many flip you have to make? 2, which is stored in your count. So I just update my answer as 2 because my answer is maximum, right? If I compare with my count variable, right? After that, I equal to 1. Again I count, which is 3. Again I compare with my answer. Your count is 3, but your answer is 2. No need to update, right? And when I equal to 2, here again my count is 3, right? If you see 1, 2, 3, no need to update it. If you see in this direction, all are zero, right? All are zero. If all are zero, your count is as big as it is, right? So no need to update your answer in that case. So my answer here is 2, right? Again, at particular standing bit, I just compare my answer with my count and update my answer. At the end of my this outer loop, what I'm doing is I just simply return my answer variable. Okay. So let's move to next question. Okay, so yeah, the next problem is GSP interview, right? A little bit interesting problem, right? Okay, so let's first understand this problem better. So if you see here, what we are doing is there are n aspiring geeks arriving at different times for their interviews, right? Geek selection board interview will be there, right? Now, each geek arrive time is given by arrival time, right? So, if you see the constraint part, here we have like the input part, we have the n value which is 5. It means we have 5 students which came to the interview, right? And at what time it came, that will be stored in your answer variable name as like arrival array, right? So, for example, here 43693, it just tell you that that particular student, first student came at 4 a.m, 4 p.m, nothing anything you can assume. Okay, so after that another student came 3 and 6, 9 and 3. That's it, right? After that the GSP can organize up to m interviews, right? Maximum they can like arrange m interview sessions. So the m is just tell you that how many sessions they create. It's m. Now, in each session, how many geeks can participate, right? How many geek can be there, right? Maximum limit is k, right? Okay. So our goal is just to arrange the interview session so that the longest waiting time for any student or geek is short as much as possible, right? Okay. Now let's understand how this, how, which, what the problems are to us. Let me write the same test case first. And the value is 5 and m is 2, k is 3, and our arrival time is this, that is 43693. Okay, so what are these are just arrival times of your n students. We have 5 students. So the first student came at 4, second 3, 6, 9, 3. So these are the arrangement of that. So they tell you maximum sessions we can create is 2. Inside this session, the maximum student came is, there is a limit, right? In this session, maximum student came k. Here also k. Now we just have to arrange the students in our sessions as such as like the maximum waiting time will be the minimum, right? The waiting time for the particular students will be minimum. So let's arrange first. Let's arrange first how we can arrange. If you see here, if I, this is a first student, so the limit is k means 3. Let me write here 3, here also 3. Okay. Now, is this a 4? This student can came in this session. Yes, it is. Let me add this. Again, I am adding 3. Again, I am adding 6. Right. Now, can I add 9? No, because the limit is succeeded, right? Like 3 is already filled, right? 3 students are already filled in session 1. Okay. So what I'm doing is let's create another session which is M2, and I am like putting that particular student here, right, at this m2 session. Now 9 came here and 3 came here. Okay, so yeah, it's filled. Now let's calculate like what's the time, waiting time here. So let's understand first the waiting time, a little bit of it. What's the waiting time is, for example, like 2 students came to the interview on this session. The first came at 2, and the second came at 6, and another came at 8. But the condition is when all are at the session will start at that particular time, right? Because this student came at 2, this came at 6, this came at 8, means all are in that particular session at a, right? So we have to start the session at a, right? But how much maximum time a particular student have to wait? So the maximum, this have to wait 2, but this has to wait 6. What is the maximum? It's 6, right? So the waiting time is very simple. Like what's the minimum and what's the maximum? We just have to subtract it, and that's the waiting time, right? If you see here, if I segregate my n student like this, what's the waiting time here? 6 minus 3, which is 3. What's the waiting time here? 9 minus 3, which is 6. So what's the maximum waiting time here? It's 6. So that will be your like first case. We can segregate our student like this, right? Now let's move to the case number 2, like how we can segregate. If you see here, we just have to like subtract the minimum and maximum value. If I club all the students which came at nearby time, so that is the case where my answer came, right? If you see here, if I add here 3, and we have 2 3, right? Let's add 3 also. A k limit is 3, it means I can add here 4 also, right? Now we have 6 and 9. Let's put in this section 2, right? Session 2. So what's the difference here? What's the waiting time here? Waiting time here, maximum minus minimum, which is 1. What's the waiting time here for this students? It's 3. So that's why our output in this case is 3, right? Our output in this case is 3. Now let's check for the another case. If you see here, we have k limit is 5, and we have n4, and session we have 1. If our session is 1, it means all the students n student have to came in that particular session, right? So if I put 2 2 4 5 6, so in this case 2 4 5 6 came to the m1 session, because I have only one session, right? And limit is k, it means I can add all four students. So what's your answer? This is minimum, this is maximum. It means that particular student have to wait 4 hours, right? That is 2, that is 1. So our answer in this case is 4, right? So maximum waiting time here is 4. But our question said we just have to make as short as possible, right? That's why we just make a 2 cases. This is the first case, this is the second case. If I make that student in a particular session that are close to each other, right? That is the minimum answer we can get, right? So hope you understand the question. Now let's understand how we can solve this, right? Let me make again this n is 5 and m is 2 and k is 3, and our array is 4 3 6 3 9. I hope it's this 6 9 3. Okay, so no issue. Let me correct this. It's 9 3, right? Now I hope you guessed the first intuition how we can solve. We just have to sort this. The first step is sort your array. Okay, if I sort this array, how it look like? It's look like this: 3 3 4 6 9, right? Okay, now so let's make a number line so that we can assume like what is my minimum answer and what is my maximum answer. So what is my minimum answer? Minimum answer may be 0, right? And what's your maximum value? Maximum answer, maximum waiting time may be. So maximum time is depend upon your maximum value and minimum value. So the second is your low is 0 and your high will be So if you see here, in this case, if I put all the students in a particular one session, so 9 came into that session and 3 also came to that session. So what's the maximum value? Waiting time, it's 6. So high is always array of n minus 1 minus array of 0. So what is this? It's 6, right? It's 6. Okay, so this is your low and this is your high. Okay, now what we have to do is, let's make a midpoint here. So let's make mid is 3, right? Your mid is 3. If your mid is 3, what tells your mid? Mid tells, hey, please check for that waiting time. This is your waiting time, right? If I check, this is my lowest waiting time, this is my highest waiting time. I just search in the middle of it. If this is my waiting time, I just pass to another function if possible. I just create if possible function here. Let me write here third step. We have to create if possible, and that particular possible function tell me your mid can satisfy all the sessions. Like in a particular session we have k students, maximum limit is, and you have the m sessions. Are you like in this range or not? If you in this range, your if possible tell you, yeah, that will satisfy your conditions, that will satisfy the m condition as well as your limit on that particular session, right? So just assume, till now just assume that if possible, if it's give me true, what I am doing is I just create here answer variable and I am storing my answer as mid. Okay, I just do the whole dragon. First I just give you outer look of this question. Okay, so if my mid, this is valid, right? If this waiting time is satisfied my m sessions and k limit on particular session, what I'm doing is I just store my mid into my answer, right? When I store my mid into my answer, what I'm doing is, as question said, I want as small as possible. So I just create, I just like shrink my high, right? I just shrink my this array a little bit, this, right? I just cross this part and your high will pointing to this part, right? Now your high will pointing to 2 and I'm searching between these two values, right? And suppose that your mid is here. If this is not satisfied, if this is not satisfied, it means that will not be your answer. So what I'm doing is my low is pointing to this part. Again I checking in the mid of it, and when this low and high cross each other, so whatever your answer will be stored in this variable, that will be your minimum possible waiting time, right? Now let's make a pseudo code of this, this part. So let's do the step by step part. Okay, so let me first sort. I do whole trirem. Okay, so let's first do a little bit of it. Okay, so I just sort this, and my low is pointing to, as I said, 0, right? Now my high is pointing to arrival of n minus 1 and arrival of 0, right? That will be my low and high point. Now what I'm doing is I just create a this while loop and checking the midpoint. So mid is low plus high by 2. Okay, inside this I create a is possible function. Is possible function, please don't go into depth of it right now. I'm just writing that part. I'm passing mid and n, m and k, right? And this arrival part. If this is true, my answer will be mid, and what I'm doing is my high will search in the left part and mid minus 1, because I already stored mid, right? And else part, what I'm doing is low is pointing to the mid plus 1 part. At the end of it, what I'm doing is I just return the answer variable. Okay, now let's first understand the whole problem. Let me Okay. Now, if you see here, your mid is this, which is 3. Now let's ask as 3, right? Let me erase this part. Okay. Now, if you see here, your mid is 3. Okay. Now, inside this, what I'm doing is, let me erase this also. So, my sessions is 2, right? What I'm doing is, I create here count variable, which tell you how many sessions you are created to solve that particular question, right? So your count is 1, and your current will tell you that how many like students will be entering into that particular sessions. Let's suppose it's 1, and your first variable here is, which is starting point, which is array of 0, right? Now what I'm doing is, here I'm creating m1 session, right? Inside this, what I'm doing is, my count is, I am adding 3 into my m1 session, right? Your first session. Okay. Now your count will represent how many sessions you are created. Okay. As I already tell you. Now current will tell you, hey, you are adding that particular student into your particular session. Yeah, I am adding 3 into my particular session. Okay. It means m1 is start. That's why your count is 1. You are adding first into your m1 session, that's why the current value is 1. Current means in your particular session how many will like geeks will be there, it's 1. Now my I is here, and your first is this, right? Now I just compare that, right? If you see here, my for loop will start from I equal to 1 till n. And what is the condition when the particular is not, I'm not able to add that I position into it? The first condition is, when your current means the limit size, if it's equal to k, right? If it's equal to k, I am not able to add that particular I student into my m1, right? Session 1. Okay, that's the condition. And if their difference is greater than mid, right? If my difference here is greater than mid, that is also the case when I am not able to add, right? Okay. So here I am written current equal to k, or array I minus first. Let me write again this. Okay. So here if you see, the first simply tell you like this is the first element in my particular session, right? That's why we are just comparing with my first value, because that is the smallest in that particular session. If you see here, current equal to k, no, it's not. Or array I, which is 3, minus first. Is this greater than mid? It's not. It means that you can add that particular into your current session. So what I'm doing is, I simply current plus plus. Current plus plus tell you that, hey, you can add this into your m1 session. And here I'm increment k, sorry, I'm increasing the I value, right? Okay, so this is not going to the checkpoint, simply they just current plus plus. So how many current is the count of your students in the first m1 sessions. Okay, now when I'm at this place, again I compare, is this current equal to k? No, because your current is 2, and array I, which is 4. is there difference with first value, which is 3? Is this greater than mid? No, it's not. So you can simply add that student into your M1 session. So that's why I just increment like my current value, right? So now your current is 3. When my I reaching to this part, right? And when I go into the if case, current equal to k, yes it is. Yes it is. It means you have to create another session, right? So what I'm doing is I create another session. And for another session, as I already tell you, that will be like count plus plus. When I count plus plus, my M2 will create it, right? Now my count is 2, right? When your count is 2, nothing is there in your M2 session, right? No student will be there. So what I'm doing is I create current equal to 0 here. And inside this your particular session, what is the first student which came to your this session? So that's why here first is updated as array of I, right? So current count plus plus, I already tell you like M2, right? Now current is 0. I know that nothing is there. That's why current is 0. Now your first is array I. What is your array I? It's 6. Let me add. When I'm adding it, I'm not adding it. Just visualize this part. Okay. So after this if condition, I current plus plus. Current plus plus means the one student came into your this session. Okay. Now when my I reaching to this case, okay, when I is there, current equal to no, it's not. Or array I is 9. What is your first element in that particular session? It's 6. Is this greater than your mid, which is 3? No, it's not. 3 is not greater than 3. It means that you can add 9 into it. Okay. So what I'm doing is I'm not going into the if condition. I simply current plus plus. When current plus plus, it make 2. And when I move forward, it's out of bound. So here, your current limit will be checked by this, right? Now, when your for loop will finish, okay, so limit will be checked inside this. Now we just have to check, are you using like sessions greater than m? So how can that will be stored with count, right? So I'm returning simply if my count is less than equal to m. In that particular case, you just have to return true, right? If your count is greater than m now, it means you are just using extra sessions, right, to segregate all the students for that particular mid, right? So that's the case of it. So if you see here, count is 2 here, right? Because I created 2. But your session will also 2. It means that satisfy your if this condition. Count equal to m, right? So in this case, what we are getting is, what we are getting is, are getting if condition is satisfied, right? So inside this part, I go into the if case. I simply store my answer as my mid. What is your mid? Mid is 3. And if my mid is this, right, I want the minimum, right? I want the minimum. So no need to go for this case, right? As I already tell you. Okay. I hope you understand right now. No need to go for this case. What I'm doing is mid is already stored in your answer. So no need to include mid as well. So what I'm doing is I just create my high to mid minus 1, right? Okay. Now it's high time to check for this case in this binary search. Till now, if anyone want to ask anything or you understood this part, okay, so I will tell you like afterwards when one ly we are using. In this part, if anyone want to ask anything till now, okay, let's move forward, right? So in this case, as I already tell you, like I just stored my answer as 2, answer as 3. Now let me make this as 2 now. Okay, so your high will be 2. Okay, now if your high is this, what is your mid? Mid is this, right? Mid is this. If your mid is this, which is 1, again you have to check for this is possible case. This is a pseudocode of is possible. Let's do again dry run for this case. Just see, like, this is not working for this case. Okay, so please focus on this part. When your mid is 1, right? Let's see. Now your current is count is 1, current is 1. It means you are adding the first value into your mid one, M1, which is 3. Again, my eye is here. Is this valid? Yeah, it is valid. Because 3 minus 3 is not greater and you have the limit. What I'm doing is I'm adding 3 into it. Again, I go forward. This is I, right? Is this valid? Yes, it is valid, right? It's added into this case. Okay, because 4 minus 3 not greater than 1, right? It's 1. Okay, now when I move forward, I is there. Now if you see here, your current array I is 6 and your first is 3. Can I add this? No, because your limit is succeeded. Because your limit is k, you already add k values into it. Okay, now what I'm doing is I go into the if case and I create count plus plus. Count plus plus means you are created another session, and here current is 0, and when I'm adding first is array of I. What is this? It's 6. Now after this if condition, I increment my current plus plus, which tell you are added 6 into it. Okay, again when my I is here, is this limit succeeded? No, it's not. If 9 minus 6 is greater than 1, yes it is. You are not able to add this into it. Okay, so in that case I create another session which is M3, and current is 0. First is array of I, which is 9, right? And I increment my current plus plus, which make it's 1, right? I'm adding 1 into it. Now your loop will finish, right? Now please focus here. Your count is depend upon M3, right? M value, which is 3. Count is 3. Now I'm checking. What is your count? Is 3. Is this less than or equal to M? Not it. It's not. It's not. When it's not, they simply give you. They simply give you. Okay, so it simply give me. It's not satisfy the if case, right? It's not satisfy the if case. It's go into the else case. When it go into the else case, what we are doing is we just do low equal to mid plus 1, right? I'm not getting my answer here. I'm not getting my answer here. If I'm not getting my answer here, not possible here. So my count, now my low will go mid plus 1. Mid plus 1 means here. Okay, it means that your low will reach to 2 where your high it is, right? Okay, now your low is here and your high is here. Okay, low is here, high is here, mid is also here. Again, when you do the dry run for this case now, again it's not satisfied. Okay, again your session will be more than, like, your count will be more than your M, right? Again it's not satisfied. When it's not satisfied, please do the dry run this case by yourself. Like, it's similar, right? It's similar. If you understand this, it's similar. Okay, so again what is happening is, if possible, for your one, right, for your yeah, for your 2, it's not satisfied. 1 is already calculated. For 2, it's also false. When it falls, if you see in this case, if not satisfied, low is mid plus 1. When the low is mid plus 1, means low is 3. So it means that they cross each other. We have to stop. And what we are stored in my answer variable, we just have to return that, because that is my answer, right? That is my answer. So let's fulfill this code. So here we have to return the is possible case. So in the if possible, let's first add the mid. Then we have the n value. Okay, then we have the M, and we have the K, and we have the this arrival array. Okay, so the first case is count. As I tell you, count simply tell you like how many sessions you are created, and current will tell you how many elements, how many students will enter into your first session. So I'm starting with my like first session, which is arrival of 0, right? And now it's time to run your loop from I equal to 1 till n. Okay. Now what we are doing here is I am asking, is your limit succeeded, or the difference between your current and your first, difference between your current minus first, if it's greater than, if it's greater than your mid, right? If it's greater than mid, in that case, what you are doing is you create another session and make current equal to 0. What is the first student which came to that particular uh, session, that is represented by first, which is where you are standing right now, right? After you putting the first into your particular session, do the current plus plus, and when your whole loop finish, just check, are you using the count under a limit or not. If it's under a limit, yeah, they give me okay. Your if possible for that particular limit, it's valid. Just store that, and what's your main task? As smallest as possible. So what I'm doing is I just change my high to mid minus one, right? Okay, so this is a simple intuition to solve this. Let's check it's working fine or not. Okay, so yeah, here we have answer was not declared. Okay, so we just have to declare answer. Let's make as big as possible, which is yeah, int max. Okay, yeah, it's working. Let's submit and check. Okay, yeah, it's working fine, right? It's working fine. So, anyone want to ask in this question? You can. Let's wait a minute for that. Yeah, the fourth question have a glitch. Okay, so no issue. You just have to solve three questions. Okay, no issue for that. Okay, so let's talk about its time complexity now. If you see here, my first step is sort the array, right? Sort the array. So what's your size of this array? It's n, right? N. So what's your sorting case? Sorting take n log n. So let's make here first as n log n, right? Now let's move forward. Now if you move forward in this while loop, what we are doing is either we are going to the left part or going to the right part. It means we are just doing the binary search over here, right? Now it means your binary search on your array of size n will be log n, right? But inside this, we are using is possible function. Inside this if possible function, let's move to the if possible. If possible function, we are traverse our whole array, right? In the worst case, we are traversing our whole array. So what's the if possible like time complexity? It's big of n, right? Now in the while loop, as I tell you, the outer will be log n, but you are implement on whole array binary search, right? So n log n will be the this code, right? This code is possible will give you big of n, and in this while loop we are just doing the binary search either left either right, so it's n log n, right? So sorting part give you n log n plus this part will give you n log n, so your complexity will be 2 into n log n. Okay, so you can say that it's big of n log n. Okay, so yeah, all the questions are completed. If you want to ask anything, you can. Yeah, many are asking like why we are using 1L Okay, why we need to L in this case? In this another platform, it doesn't need to give L or R, but in G. Okay, so Gauri Shankar, like if you see here, in this case, let's okay. So if you see here, what we are doing, what's the question said? Your vector will be in the long, right? In the long part, right? Long means its data type will be very large. Why? Because here in the constraint you already tell you, it value may go 10 raised to power 18, right? If your value is in the range of 10 raised to power 9, you can use the int value. That's why here you are given the long, right? Your data type is long. When here in this if condition, in line number 17, you just compare, you just doing the and with long array j is of the type long, right? When you do the and with this now, your 1L should be there, right? 1L means that one will be long type, or you can explicitly write you can write also in another like variable, make another variable of long type, and just do the comparison with the do the and with array of j, right? That's also fine. But here like in a single line I have to write this. Okay, yeah, if possible 158 will be discussed, right? So right now we are in 159. So if anyone want to ask anything, like we have couple of minutes more here, you can ask in this three questions, right? So let's wait another a minute, else we can wrap up this. Okay, so yeah, anyone want to ask anything? Okay. Somebody joined late. No issue. That will be like recorded in our like channel. Okay, so you can. Okay, so yeah, we can make a candy distribution like that problem explicitly. Okay, no issue. Like tomorrow or day after tomorrow, we will be share that problem in our channel. Okay, if possible, we can. Okay, so no issue for that. Take care. So yeah, that let me give you a hint. That problem is also based upon our binary search. Okay, so that's also very easy problem. Just do it by yourself. Like okay, yeah. So, okay, guys, thank you for joining today's session. I hope you enjoy. Okay, so yeah, if anyone have any doubt, he or she can like comment in this like in this recorded video. Okay, so we will like see that comment and will reply on that. And what's my humble request? Please like this video. Okay, so yeah, that's it from my side. Okay, thank you so much for joining. Okay, good night to all.